Graph the solution to the following system of inequalities. Y is greater than negative x plus 1, and y plus x squared is less than 5. Let's do part A. We're going to try to satisfy this system of inequalities with shading, right? Inequalities is about shading. Inequalities is about shading the true region. We do have two of these. First thing we want to do is draw your axes. And in your own way here, make sure you could graph these equations correctly. So this one here, I want to graph y equals negative x squared plus 5. I'm going to pick on the parabola first. They're both going to be dotted. So I got to go 5 units up. There's 5. Maybe I should color that in black. And what else do we have there? So we're going to have a parabola like this, like that, and like that. Okay, another mark here. So I could quickly graph the parabola. It's going to be a dotted line. It's opening down. There's a region there. Now we got to graph the straight line. Y equals negative x plus 1. So we start with the y-intercept. Start with the y-intercept. And then we go down 1, right 1. And then draw a straight line through here. It's also dotted. So there are a lot of regions here. Let's look at this carefully. We need to pick, well, there's an intersection here. And there are a lot of regions. There's a region over here. There's one. There's a region out here. There's another region. There's a region on this side. And there's a region even over here. Now, let's see. What we're going to do is test the original inequality for both of them. Now, a convenient point to test is the origin, 0, 0, because the origin is not on either graph. So let's start with this one. Is 0 greater than 0 plus 1? And that is false. So I tested the line, and I got to shade the true side. So I got to shade this way, and this way, according to that statement. Let's test the other one. We're also going to test 0, 0, but we're going to test it in the other inequality. Is 0 plus 0 less than 5? And then this one is true. So this one involves the parabola. For the parabola, I do shade the 0, 0 side. So for the parabola, I'm going to shade this way, and this way. So where do these two arrows overlap? Where do we actually intersect all the shading? And the answer is right here. We got some blue, and we also happen to have some green. So that is the solution to this particular system of equations. What should you show for your work? You should definitely show your test points. You want to be able to graph those equations quickly. So you want to show that. Let's do another example just to get some variety. Let's go to part B. Take my handy dandy eraser. Squeak, 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 squeak. Let's move part B to be a little bit friendlier on the left here. part B. That first equation is a nonlinear equation. Well, it's actually an inequality. I need to make sure I write the equation associated with it. It's actually that. And that is actually the standard form, or it's in the standard form of a circle. This is x minus h, quantity squared, plus y minus k, quantity squared, is equal to r squared. So this is a circle with radius r greater than 0. And we also know the center. The center is hk. In our case, you can totally see that it's x minus 0 quantity squared plus y minus 0 quantity squared is equal to 9. First thing you want to do is graph that dotted circle. How do you graph a dotted circle centered at 0, 0? The center is the origin, but the radius, you already know the radius, r is 3. So you actually know 4 ordered pairs. You got 3 here, negative 3 here, 3 here, and negative 3 here. And then we simply connect the dots. Why don't we draw that circle? It's a dotted circle. There's no equal sign on the inequality, so it's dotted. Now we got to graph the parabola. The parabola says it's an opening down parabola, and there is a y-intercept at 0, 1. And when x is 0, y is 1. When x is 1, we get 0. So it actually goes like this. There's a parabola going like that. Once again, we have many regions. We have a region inside and outside the parabola, and we have a region inside the circle and outside the circle. Let's test both inequalities. Once again, we could pick 0, 0 for convenience. X squared plus y squared is less than 9. Is 0 squared plus 0 squared less than 9? The answer is yes, it is true. So you need to shade inside the circle, like that. Let's test the other graph, or the other inequality. The other original inequality is this. Is 0 less than 0 plus 1? And that is true. So we're shading the 0, 0 side for that as well. So we have to shade inside the parabola like this. So once again, where do the two kinds of arrows collide? Well, they're colliding here, and they're colliding here. And that's it. You only want to draw the intersection, or where both ordered pairs are satisfied in the true region. That's it. Let's circle our final answer. Circle your test value. You do want to show probably this, right? Standard form of a circle.